State of gaming on Fedora Workstation. A little bit background on that. It's been mostly gaming. That's how I got introduced to Linux-based operating systems in the first place. Back when I was a college student and my laptop could not run Windows, so I resorted to using something else that could run my games while, well, not being Windows. Anything, for God's sake, anything. So I turned to distributions which were popular at that point in time, the ones that had GPU drivers already in them, in the live ISO. And one of the things that I was to find that, yeah, back in the day, the performance parity of how games used to perform in Windows was a lot as compared to how it was on Linux. It was a lot slower, a lot choppier, and a bunch of games just did not run like at all. Fast forward to 2023, we live in a world where Steam Deck is a thing, and I think that huge kudos, huge props actually goes to them for making Linux gaming so popular that we actually are a sizable market share, if not a huge chunk. The majority is still Windows, but a bunch of it has actually come from the ones who actually use Steam Deck. So let's try out how Fedora Workstation acts when it comes to gaming. So the things that I will discuss about in this presentation is how one who is just a user of Fedora Workstation, they don't know any technical details as to what goes inside of it, but they will still be able to set their distribution up, install whatever's necessary, storefronts, support applications, you name it, and finally be able to play games and analyze how they can have a better performance at that. So when it comes to setup, we'll set up Fedora Workstation 38 over here. For the storefront, we'll install Steam, and the video game that is in focus for this presentation is Forza Horizon 5. It took me a while to benchmark this. If you have been following my blog posts and the talks that I have been doing in the previous release parties, Nests, as well as in FOSDEM as well, I have been doing this consistently, taking Fedora Workstation for a spin. I have this AMD machine on which I install these, and then I compare performances against the most recent version of Fedora at that point in time with the most recent version of Windows, and see which one is better and how we can do or achieve better performance in our platform. So I'm going to walk on Joseph's footsteps over here. He compared Mastodon with Twitter, so I'm going to compare Fedora Workstation with Windows 11 and see how we fare as compared to the performance that we get to see over there. So moving on to the next slide. Yeah, so setting up. It's, wow, I actually have reused a bunch of my assets for the presentation from the last slides. That includes the 3-step procedure because, well, 3 steps. That is how you make things sound easy. So yeah, just visit the website for Fedora Workstation, that is fedoraproject.org/workstation. Download the ISO file and verify it to make sure that you have the correct ISO file and the download has not given you an inconsistent file, let's just say, for instance, and then flash it on a drive, give that live environment a spin. And if you seem to like it, which I think you will, install it and give it a try when it's installed. Then setting things up. So if you have an NVIDIA GPU, the steps have become so darn easy compared to how it was years before. The only thing that you need to do right now is open up the GNOME software, enable the repositories to have access to the non-free proprietary drivers of NVIDIA from RPM Fusion. Once you enable them, refresh the repositories, and you should be able to see that, yeah, the graphic drivers, the most recent versions of that are available to be downloaded and installed. You don't even have to touch your command line or terminal application one single time to make this thing happen, proving the point how easy it has become for people to just use Linux as their gaming environment. They don't really have to be developers or Linux enthusiasts for that, you know. For AMD users, on the other hand, well, the steps are actually a lot more easy. We didn't even need 3 steps for that matter, because guess what? These drivers, they're already installed. So the only thing that you can do probably is to make sure that they're up to date, because these drivers are free and open source in nature. Huge kudos to AMD for that. It enables us to do so much more by having the drivers available from the very get-go in our distribution. Then once we are done with the setup phase, we'll install our storefront, which happens to be Steam in this case. Even for Steam, all you need to do is enable the RPM Fusion repository for Fedora 38. And once you have done enabling that, refresh the repositories to make sure that this is available for downloading. And once it's available, simply go ahead and install it. Forza Horizon 5 is available across multiple storefronts. I think it's available on the Microsoft Store for Windows users as well, but we're going to use Steam over here because Microsoft Store is not available on Linux. And frankly, Steam has a bunch of good offers coming every now and then. So I always keep an eye out to make sure that, yeah, I do get the video games in a much cheaper prices. And this is probably why I was not able to test Forza Horizon 5 earlier. It was on the full MSRP for a long while, and then it became a lot more affordable in the sale, and I quickly grabbed it. Right, so once you're done installing Steam, the next thing that we'll do is we'll install the Proton compatibility layer. For that, you're going to head over to the settings window, and the last option over there is called Steam Play. If you were to go and install Forza Horizon 5 directly without it, you'll see that, this is only available for Windows. This is showing because you don't have Proton installed. But once you have that thing installed, I'm going to select Proton Experimental over here because it's the most recent, the latest and greatest stuff. So chances are that it's going to help my games perform in a much better way as compared to, say, the previous versions of Proton. But your mileage may vary. Certain versions of Proton perform good in certain games, while you kind of are better off using the older versions of Proton. So it's kind of a mix and match thing to see what fits you the best. But if you just want to get started with stuff, then Proton Experimental is your best bet. So once you click on that drop-down menu and then click on OK, it's going to restart and download certain dependencies, certain support libraries that's important for Proton to run. Proton uses Wine in its backend, so there you go, Wine assets that will be downloaded by Steam. And once it's downloaded and once you restart the Steam application again, you should be able to see that this game is actually available for installation. You don't need a Windows PC to download stuff from there, to copy stuff over to your Fedora Linux installation and run it, because Fedora Linux can have a storefront natively installed and can have applications, games from that storefront installed as being a one-stop solution to all the gaming. And here is a screenshot of me downloading the video game. It requires me to accept this end user license agreement, which I do. And then it's not just a game that it downloads a bunch of Proton experimental libraries that's required for that game to run in its best performance, and a bunch of runtime things. In this case, it is Steam Linux runtime called Sniper. Bunch of different things. So for the most parts, you really don't need to care about what that is, but for the ones who are interested to know about how things work, this might actually look interesting. Then finally, once you're downloaded the video game, it's the time to play it. Log into your account and you should be able to run the game. No problems with that. Right, so now that we're able to run the game, let's actually benchmark to understand how these platforms perform. We're going to have Windows 11 22H2, which at the moment of presenting this presentation, is the most recent version of Windows out there. And we have Fedora Workstation 38. Both of these operating systems are minimal in nature, so we did not install anything else apart from the storefront, the drivers, and the video game itself to make sure that there's nothing running in the background or anything that can hamper the recordings that will be done in the benchmarks that will run. So Forza Horizon 5 has an in-game benchmarking tool which is quite diverse. It's really extensive to help you understand what performance you can get on a selected setting, and based on the hardware that you have, what performance you should get to get the desired frame rate while maintaining the best possible visual fidelity. So we're going to benchmark it on Windows 11, then Fedora Workstation, and then combine those results to compare which one performs better than the other one and the reasons behind the better performance, also understanding why the other device or the other platform does not perform as good and what can be done to make sure that that performance is better. Right, so here's the hardware on which I'm running these. So I have a CPU of AMD Ryzen 9 5900X, AMD Radeon RX 6800 XT. So just because I had an AMD GPU, I did not have to say download drivers or enable repositories to do that or anything of that kind. All I did was I installed Fedora Linux and I updated the packages, which includes driver as well. So I am running the most latest and the greatest version of the driver that's out there. The memory is 32 gigs of DDR4. I have two memory slots, two memory sticks, so it's dual channel, 3600 megahertz. X570 chipset for the motherboard, and the cooler is a standard air cooler. For some reason, I feel a bit paranoid while using the water cooler. And the power supply is an 850 watt gold rated power supply from Corsair. It's RM850X. Right, so now that we have gotten that out of the way, let's move on to the benchmarks on Windows 11 22H2. So take your time into understanding these graphs. The link to this presentation is also provided and it's pinned in the chat section. So I won't be spending much time over here. Do take a look at those when you find time. And I will be writing a follow-up blog post on Fedora Magazine, which goes a lot more in detail as to how the governors for the CPU can be a bottleneck for the GPU. So do keep an eye out for that. But right now, the frame rate benchmarks for Windows 11 22H2 proves that the most frame rate is recorded in the very low preset, and the achieved one is the one that's calculated as an mediated average for the CPU simulated, a CPU rendered average, and a GPU average. So it is a maximum of 281 in the very low preset, and it's going to the minimum of 103.5 in the extra preset. So just to be clear, extra preset is something that does not exist in the game. The highest preset in the game is extreme, where every setting, well, or the most settings are turned to their maximum. But when you set those settings which are still in their high preset and not to their maximum, that is where you get extra. So it's crazy, it's mind-numbing crazy, because you don't need that much of visual fidelity, and it's kind of a diminishing return thing, that the more you start focusing on making your graphics look better, you lose out on exponentially greater frame rates than actually seeing any difference that could be of value. So over here, you can see in green, 281 in the very low and 103.5. And you see that, yeah, there's actually quite a decline from the maximum to minimum. That's around 63.17% of a decrease. And in this platform, ray tracing is actually available. So you can be sure that in the extra setting, ray tracing was amped up to its maximum. With the most recent update to Forza Horizon 5, ray tracing was actually included in the world and not just in Forza Vista, that is like a photo mode for the game. So this was actually a great way of understanding the ray tracing performance across platforms. And keep in mind the percentage decrease because this is going to play an important role in the comparison going forward. Right, so for Fedora 38, Fedora Workstation 38, we do see a decline in the recorded frame rates. That's 222.5 for the very low preset in the achieved section and 92 for the extra section. While this is a platform on which the ray tracing is not available, we could not amp that to its maximum potential, so ray tracing was absent throughout all these runs on Fedora Workstation 38. The percentage decrease is a bit better than the last one. As compared to something over 60s, we have 58.65, which essentially means that the performance is mostly maintained across these presets. So for someone who were to decrease their performance preset or graphics preset just because their Steam Deck or their laptop is low on battery, chances are that they won't see a lot of difference in the frame rate as much as they would in the visual fidelity, but that's something that's mediated by the video game itself and not the platform. So there is a decline, that's totally understandable, but what actually goes into it, these settings, because some settings have stayed the same across the multiple presets that I have tested these frame rates across. So the resolution has been kept as 2560 x 1440 exclusive, which essentially means that you can't share your inputs seamlessly across multiple windows, multiple monitors. All you need to do is kind of alt tab out, but it does make sure that your application gets the complete control on the frame buffer, thus improving performance. And the parity by which it improves performance, it differs from video game to video game. The next is HDR being disabled, vertical sync disabled to make sure that we actually have no limits to the refresh rate of the monitor. The frame rate limit is left unrestricted. Anti-aliasing is disabled, and resolution scaling is also set to 1.0. So no downscaling, no upscaling whatsoever. Right, so finally we come down to the comparison part. This is where we get to know about the frame rate achieved, and as you can see that the general trend has been that Fedora Workstation on Wayland has been performing a bit worse as compared to Windows 11. But that worse actually becomes a plateau as you go on to the extra settings, because the 92.05 and 92 frame rate differences can be calculated as the margin of error. So the maximum difference is, of course, 270 and 222.5, with it being 17.590, and the minimum is 0.054 in the extra one. And this performance is actually achieved while using much lesser system memory as compared to the competitor. So Fedora Workstation uses 27.834% average less system memory and 21.396% of lesser video memory across all these presets, and still delivering an similar, if not an identically same performance. And this essentially means that using lesser system resources could make it worthy of being used in devices that are, say, battery powered, handheld devices, laptops, and lesser consumption could mean that you can play the video game for a longer period of time. The next comparison is run for multi-sampling anti-aliasing in the high preset. And for the most parts here again, it has been seen that Fedora Workstation generally performs a bit worse as compared to Windows 11, and the consistency is maintained though. The most it gets down to from 151 is 136, while on Windows 11 it gets down to 166 from 192. So it's kind of 23.03 when it's switched off, multi-sampling anti-aliasing, and it is a maximum of 18.07 in 8 cross multi-sampling anti-aliasing preset. So as these presets go on becoming more and more advanced, the differences actually go on decreasing to a point that it's almost marginal. But F38 manages to remain constant in off as well as in 8x. So it's generally recommended to run your video games at 8x because the margin of or the impact that it has on the frame rate when you go on higher is much smaller as compared to the one that's experienced in Windows 11 22H2, which falls straight down from 192 to 166. So yeah, you definitely get a better picture quality if you were to have a greater multi-sampling anti-aliasing. Right, so let's talk about how exactly is the GPU held back by the platform or by the nuances of the platform. So say for instance, the Fedora Workstation 38 has CPU performance actually bottlenecked by the CPU. So it's significantly high from the low preset, and from onwards, it's actually getting started on Windows 11 22H2 from the low preset onwards. What does that actually mean? It means that as these presets become more resource intensive, it kind of gives the CPU a reason to start bottlenecking, and it actually differs from across multiple reasons. So for Windows, it can be a number of reasons why it can be bottleneck. For Fedora Workstation, it can be a bunch of reasons why it's not able to spread its wings in its entirety and fly and actually get more performance. But there's a silver lining. It's the CPU governor. Here again, this is something that's a bit more advanced. So if some people just want to play their video game and call it a day, you don't need to touch it. If you get 60 FPS, I'll call that a playable frame rate. It's much better than the ones that is actually accessible on consoles for a previous generation. 60 FPS is kind of a norm in the consoles for the current generation. So if you get 60 FPS, that's it. You don't really need to tweak your stuff around. But changing the CPU governor from, say, power save or sched util to performance or on demand, it actually ends up increasing the performance, and we end up getting better frame rates. Although the difference can be marginal and it's only visible when you actually analyze it. But when you're playing the video game, the jitters are gone. Back in the day, this game could not even run, but right now it's all smooth, although there is definitely a scope of improvement. Right, so a final couple of slides.
We're in the
Go ahead,
last
Justin.
Just want to give you a time check.
Sure thing, thanks. Much appreciated, because I don't see the chats and everything, so thank you for unmuting and giving me that. Right, so last couple of slides as to understanding why you would want to use Windows 11. So definitely Fedora Workstation is hanging behind in terms of ray tracing and HDR. So if you are looking for these features, and if you have a hardware that supports these, Windows 11 should be a go-to thing for it. Plus the raw performance. Sure, it's using more RAM, more VRAM, more power, but you do end up getting more performance over there. But when it comes to Fedora Workstation, it is actually about efficiency. So it's a lot better suited on, say, laptops, on handheld devices. So great frame rates are achieved. The impact is not as much as the consumption of RAM or video memory. So for lesser video memory, you get actually similar frame rates, and it still works on low-end devices. You don't really need a very high-end device to first run your operating system first, and then your video game. And finally, portability native. Less battery consumption means longer playtime. Right, so that's about it. I wish I could show you some gameplay, but I don't know the legality around it, if I would be able to do that or not. So I'm gonna follow this up with a blog post on Fedora Magazine down the road. But here are the links. You can connect with me using these. And yeah, I really hope that you will give Fedora Linux a spin, no matter which spin you use, KDE or Workstation, like I did for this one. But do give it a try and let us know about your experiences. Right, let's see if we have any questions. So the first question is about the experience for using hardware for CPUs AMD versus Intel, for GPUs NVIDIA versus AMD. In general, I've seen that for AMD it's a lot easier for me to use it because the drivers are open source. So for me, if I were to own an NVIDIA graphics card, I'll have to wait for their drivers to be converted and to be packaged in RPM Fusion. So it's usually a bit delayed before it comes to me. But for AMD, it's actually quicker that way. But then again, I'm not going to say that NVIDIA performs worse. They both perform comparably well. I'll select AMD just because they have their drivers free and open source. And for CPUs, I'm going to still stick with AMD because they don't have that performance and efficiency cores difference. All the cores perform in a similar way, in the same fashion. So you won't be getting these nuances about why a certain CPU is bottlenecking the GPU, because it happens quite a lot in Linux space. The next question is from Justin. Say, do you purchase or build your own gaming setup? Any advice for seeking out for ideal gaming rig tuned for Linux and Fedora? Yeah, for the most parts, so Anurag has an answer. As far as I know, he built is not own premium setup. Well, I own this setup on I don't know what you're talking about. I'll stick with AMD here again. I work for Red Hat. I don't work for AMD, so this is not a marketing pitch. But usually the AMD hardware has been giving people the most seamless performance, and you don't really have to look inside what's happening, or you don't really have to be a command line magician to be able to make things work. For NVIDIA, for the most part, it's work. We have really made things easy for folks to be able to use those hardwares as well. But there are still some nuances when it comes to things like NVIDIA Prime and things like Optimus, or those things. So it does become a bit complicated. So if you just want to set things up and play games and not worry about anything else apart from that, AMD CPUs, AMD GPUs, and your choice of coolers, your choice of power supply, I'm going to leave it to that, is the way forward. And any suggestion for DLSS and FSR? Those are some good technologies. I'm going to prefer DLSS more. It's a bit superior than FSR. FSR is, at this point in time, it's a pixelated mess, but I do see it growing going forward. But NVIDIA DLSS is a much superior technology when it comes to that. And do use them. There will be times when the performance parity and Linux distribution will be a bit lesser as compared to Windows, but that's fine. Remember, these video games are natively written for Windows, and we use a compatibility layer to be able to make them run on Linux. So the performance parity was huge back in the day. It was 50% the frame rate, but right now it's what, like 17% maximum? That's acceptable, and that's beyond 60 frame rates. So it's becoming a lot better than it was before, and it will go on becoming better as time goes on. Right, so the final question before I hand it over to the next session, do you advise the use of game scope and game mode tools for some performance? Yes, I do, but with a grain of salt. If you know what you're doing, totally go ahead, use them. And GameScope is actually pre-tweaked on platforms like Steam, on Steam Deck. So you don't really have to do a bunch of things in order to get it running. But for someone who is not experienced with Linux, it's going to be a bit difficult. So I'm going to say that, don't jump in a deep end. Try getting it to run first, enjoy the game, and then take your steps forward from there on. Because you would not want to get discouraged just because you want to get that performance when it's not even noticeable when you just play it. It's just that meter that you have on the top left corner of the screen that tells you that no, you have a lesser performance even though it's consistent. Right, so that's about it. Let me check the chat section. Yeah, thank you so much for attending the talk. And do feel free to reach out to me if you have any questions regarding Linux and gaming. I'll be so happy to help you with that.